Okay, so to add and subtract fractions, you need a common denominator. I want you to shut your iPads and just watch with me for just a minute, because I'm going to get into some stuff you're really not used to. I think you're going to get overconfident here. Shut the iPad, please. Thank you. Just shut it. Just shut it. All the way down. That way, oh, okay, I couldn't see it. Thank you. And now this is in 15ths. Why did I choose 15ths? 3 times 5, and that means when I get over to this one, what should I choose as denominator over there? 8x. Very good. Okay. Now, just go back to the easy kind in again. And how do I get this to be 15ths? Well, this 3 needs to be in 15ths, so I have to times it by what? And if I'm timesing by 5 on the bottom, I can't just go around multiplying things by 5. It changes stuff. But I can make it stay exactly the same if I also multiply the top by 5. Why? Because you're really then multiplying by what? By 1. All right, so then 5 times 2 makes 10 15ths, which is the exact same thing as 2/3. And then over here, we got 5 turning into 15 is timesing by 3. 7 times 3 is 21 15ths. And now I can actually subtract them. And notice what happens. The denominator stays the same. It doesn't go 15 minus 15 makes 0. The denominator stays the same, and the top is actually subtracted. There's my answer. Now, going over to this one, it's simpler because they're already in 12. So 3 times what makes 12? And if I put a 4 there, I got to put a 4 on the top. Like that. So it's going to be 4 12s plus 7 12s. Child's play. Easy. 11 12s. How about this one, though? Raise your hand when you think you know the answer to that one. What's 1 over x plus 5 over 8? Don't use your iPad. Just use your brain. What do you think? You got it. Yep. We know it's over 8x, and you said it's 8 plus 5x, right? You're right. How did that happen? Because this one had to get times by 8. Yes. Get times. And the other one, I should multiply by x over x. See, this one needed an 8. This one needed an x. All right, then it becomes 8 and 5x. 8 plus 5x. Denominator stays the same. All right, let's look at harder ones. These are freaky hard. Turn it to this page. Go ahead, open up your iPad.
Common denominator?
Yes, we need to find a common denominator.
Is pi. That's not very common in denominator.
What is the apostrophe?
That's just a comma. It's trying to separate them and say, what would be a good common denominator for this combination? All right, this is a little too early to get to something this hard. I'm going to actually ask you to add a page right now or get a blank page somehow, however you want to do it. And I want to give you one that would be much more reasonable. All right, we want to find the least common denominator. In other words, you don't always just want to do the common denominator. There's an easy one. Yeah, you can times 3x by 2x and make 6x squared. Could be a denominator I could use for this. But what we want to do is find the least common denominator that would work here. You're tapping way too much. All right. What is that? What are you? Okay. I'm just confused because I'm not, okay, maybe you're doing something related to this, but I'm not doing anything you'd write down.
I was just writing down that.
All right. Okay, so now, if I'm going to do this one, I'm breaking it up in little parts. Do you get that this has a 2 and an x? This has a 3 and an x. They already both have an x, but the number part is the part that's different. So what could I multiply both of them by? What would be a good common denominator where they could have a common denominator and yet not have to just go stupidly that times that, because that's just a little too easy and it comes out with an answer that's not as simple as it could be. What's a smarter way? What do you think? Yes? You could multiply both of them by 6, but there's a better way. Well, how about this? Do you agree that that there is a common denominator for these two that would involve an x? Okay. Well, should it be a 2x? No, because the other one can't be a 2x. Could it be a 3x? No. Could it be a 6x? All right. Is 6x the right common denominator? Can anybody think of anything easier that I could put them both into? I'm not saying that there is one. Do you think 6x is it? I agree, it is. From the way I was saying it, you're probably questioning it. So how can I make this one right here, by multiplying something on the top and the bottom, become a 6x? I times it by 3 on the top and the bottom. How can I make this one a 2 on the top and the bottom? Do you get what I just did there? All right, so you got to figure out what a good common denominator would be, and then choose what to multiply by to make it that. So this one will become 3 over 6x plus 4 over 6x. And again, please resist the temptation to add the 6x and the 6x together, because in denominators they just stay the same. It's equal to something over 6x. 3 plus 4 is 7. 7 over 6x. All right, I'd like you to try another one like that. 5x over 2x plus, 2x squared plus 6 over x. So my first piece of advice is break it up into little parts. The denominators. The top is simple, 5x. The bottom, 2 times x times x. Why did I do that? To show that I had an x in there, not just an x squared. That's really made up of a couple x's. And now what would be a good combo that they could both become? 2x? No. Just raise your hand, please. I'm going to go with I think if the first hand was there. You think 2x squared is a good common denominator? Okay. This one's already got 2x squared, so that's easy. How do I make this be a 2x squared?
You multiply by 2x.
You are correct. And wait a minute. Not that one. There we go. So, do you agree now that they both have a denominator of 2x squared? All right. So then I just got to figure out what's on the top, because the denominator is for sure 2x squared. Yes? Could I? Yes. Do I have to? No. You're right. I wanted to throw something on the top. I should have made it a y instead of an x so that you couldn't cancel it. I'm trying to make it so that this wouldn't be quite as simple as just adding a couple numbers. All right. So then I'm going to change it to a y. I'm going to cheat. So this is 5y plus, what's that? 12x. So it would be 5y plus 12x. Okay. So, moral of the story, finding common denominators. Let's go back. Let's go to this slide. Please go to this slide. Yes? Could I do canceling? Is that what you're asking? Since there isn't a 2 in this and this and this, no, because you can't cancel over addition. Only if there's 1 in everything. Remember that whole, it's kind of like this. Can you cancel those x's? No, because there's a plus in the middle. If there was an x in everything, could I cancel it? Yep. But not if there's not an x in everything. There isn't an x in everything there. So, all right, moving on. This slide, please. All right, this gets hard. I'm warning you. Going to be really challenging in a minute. Right now, it's not too bad. I'm walking you up to it easy, nice and simple. Okay. Would you agree that that and that have something in common? The x minus 2 part. And I'm going to put this in parentheses just because I think it'll make it match nicer. So then it's not too hard. The other side just needs, the right side needs what? An x squared. If I put one on the bottom, I put one on the top. See if we can get the final answer for that one and tell me what you think. Got it or got a question?
I have it.
Hit me with an answer.
So 5 over 6 squared, x minus 2 plus
You're just telling me the question again, but yes. The final answer is?
5x to the third.
Nope, can't put the 5 with the x to the third.
5
There you go.
over x squared, x.
You are so right. That's it. Raise your hand if you had that one right. All right. Unfortunately, either the entire class is geniuses or that one wasn't that bad. Okay. How about this class? What? This one, class. How about this one, comma, class? Does this one have the potential to have an easy common denominator? Well, not really easy, but if you can't do anything else, what do you resort to? That'll always work. Multiply them. So if I'm going to multiply them together, then the denominator, when I'm all done, will be x minus 1 times, alignment's off a smidge, it's throwing me off, x minus 1 times x plus 3. And now, how do I get that to be a common denominator? This side needs something, and that side needs something. This side needs an x plus 3. And whatever you do on the bottom, you have to do to the top. And this side needs an x minus 1. And whatever you do to the bottom, you got to do to the top. Go ahead and finish that up and see if you can get the final answer for that one. When you've got that answer, please write it. Staring deeply into the screen may cause you to think, but writing engages a different part of your brain. Helps you remember what you're doing. Really close. Something on top, I think, is messed up. Depends on what you think a big number is. Because I think the number 5 is really big. Okay, so there's this part and this part. On the left, I could have just moved that down, but I guess I'll rewrite it. On the left side, I have x squared plus 3x on top. You see where I got that? Multiply it out the top. On the bottom, I'm going to leave it. On the denominators, I strongly encourage you to just leave them. Don't multiply them all the way out. Because where we're going, they're going to get so big that trying to multiply them all the way out takes forever, and it's not worth it. And now on the right side, this side, I have 4x minus 4 over x plus 3x minus 1. And now since they have a common denominator, I can put them all together in one big fraction. And the bottom is x plus 3x minus 1. And on the top, here's where people screw up. Not this, x squared. Not that. This negative has to be not just on the first one. I could have rearranged them. That first one is kind of random. That negative has to go to both of them. So it's minus 4x but plus 4. And then these two can go together, and I will have a final answer. I'm going to go down a notch. X squared minus x plus 4 all over x plus 3, x minus 1. And I know I could have multiplied out the bottom, but you don't have to, so don't. This negative right here isn't just on the first number you see. It's on this whole fraction. Do you get how I'm subtracting two big fractions? So that means that the top part of the fraction has an imaginary parenthesis that a lot of people don't put in. You need to have that negative distributed to both parts. Okay, would anybody have gotten this right? Nice. Well, let's see if anybody can get that one right. This is getting progressively harder, and it's going to get even harder than this. But I'll give you a hint. On the right-hand side, that x squared minus 49 can factor. And once it factors, it makes this a lot easier. You don't want to try to avoid the hard stuff. If you're ever going to accomplish anything big, you have to be able to tackle the hard stuff. There was serious debate on whether the United States should enter World War II or not. A lot of people thought, we don't want to go after those Germans. The Germans are tough. They have a really strong army, and they might might not be able to take them. I mean, Hitler might beat us. In fact, Charles Lindbergh, I believe it was, I was reading a story the other day about how he had, again, I think I got the right guy here, Charles Lindbergh opposed going into the war with the Germans because he basically thought we'll get our butts kicked, and because he's just too tough. So I need people who are not afraid to do the difficult problems because they're coming up here. Yes, sir.
Charlie Chaplin actually lost his career as an actor due to his movie The Dictator, which people thought was spreading war propaganda.
Really?
Which it was basically to expose Hitler's terrible crimes.
So Charlie Chaplin was sort of, do you think he was saying we should go to war because Hitler's really bad, basically?
Yeah, he's basically saying we should go to war
Interesting.
for the sake of humanity.
Okay.
Not just like for fame.
Right. You can make a good case that the United States could have stayed out of World War II and saved themselves a lot of pain by doing it. You know, they wouldn't have had to, all that cost and all that. But in the long run, if we'd have waited, Hitler would have got super strong, and we'd probably all be speaking German right now. All right. Really? Oh, that's right. Yes. Yes. Okay.
It was a pretty fun movie too.
So now, this one. I'm hoping that you knew to factor this right side and turn it into x minus 7 and x plus 7. And that will quickly make you realize that this other side here is close, but it needs an x plus 7 on the top and the bottom. So if I can put an x plus 7 on the top and the bottom, then I'll have a common denominator, and then I can actually finish the deal. The denominator here, I've just replaced this, is that. Okay. So now the denominator here is set. Oh, wait. That's getting multiplied by that. So that's all one big answer being subtracted, or subtracting that. Okay, final answer. Put it all over. X plus 7 and x minus 7. Who got that far anyway? That you knew was x plus 7 and x minus 7. Good. Okay. Then on the top, x squared, 7x, minus 16. Raise your hand if you had that one right. Sweet. All right, we still have a hope. This one is Hitler. See if you can take it out. Now I'm going to give you a hint. You want to factor everything that can be factored. Like this you can't factor. This you can't factor. That you can't factor. But you could factor this and you could factor that. And then hopefully you'll figure out which ones, what you need to add to each fraction to make it so they all have a common denominator. You're going to have to multiply each fraction by something to make it have a common denominator. It's not as simple as x. Once you factor it, you might see, oh, this one needs a 5x. This fraction needs an x minus 1. And then they'll all be the same. All right. So while you're doing this, I'm going to tell you a little World War II story because you're trying to defeat Hitler right now. We had a problem. Hitler had this code that was really tough to break. In fact, nobody had ever broken it because he had designed a machine which, or it probably wasn't Hitler, but one of his guys had designed a machine that could be reset so that it had a different code like every month. And they reset this special code machine, and then when they'd send their message, it was just numbers and letters and dashes, and we had no clue what he was saying to his troops. We could intercept the messages, but we didn't know what they meant because he had an awesome code that we couldn't break unless you had a machine. So there was an opportunity. We found a submarine disabled out in the ocean. And that submarine, German submarine, had one of the machines on it. So instead of just sinking the submarine like you typically would, we took a lot bigger risk. It was really complicated. I'll shorten up the story, but we went in, got on the submarine, sent some some commandos into the submarine. They found one of those code breaking machines, and they got it off the submarine, and then they sank the submarine. And then the Germans thought that the submarine had just been sank in war, like they typically are. They never knew that we had one of their machines. So then when they were sending the messages, we could decode them. But we needed to not let Hitler know that we knew. And so there were times when he would, for instance, order an air raid on a city. And there's footage of Winston Churchill walking around in the ruins of a city where he knew that that city was going to get bombed, but he didn't tell the people to evacuate because the Germans would have known, oh my gosh, they've broken our codes. Because the only way they could have known that we were going to bomb that city was if they... So they needed to keep that source of information alive, and they had to let cities be bombed. They had to let guys lose battle. Lives were lost because they could have stopped the bloodshed earlier, but they wouldn't have stopped Hitler. They would have won the battle but lost the war. So they waited, and they used that information all the way throughout the war to help them in little ways that Hitler couldn't tell that they had the machine. So anyway, that's one of the reasons that we won the war, is because we knew for many of his final messages, we knew what Hitler was telling his troops to do. And that's a huge advantage, to know what your enemy's doing. Huge advantage. Do you know how one of the reasons that the Japanese couldn't understand what we were saying? The Navajo. They figured out a way to make a code that you couldn't break, and that was we used Navajo Indians to talk to each other. And they would hear, the Japanese could hear these guys talking, but Navajo is so different than any other language that they could not break it. It was like the ultimate code. So these Navajo Indians were a huge asset. They'd have an Indian in each major area, and if they want to send a code, they'd have the Indians just talk to each other. They were just talking in their own language. They didn't have to have any complicated language or code or anything. It'd be like if you knew German and nobody else did. So, and it took the Japanese forever to figure out that it wasn't a code; it was just a language. And they unfortunately for the Japanese didn't have any Navajo that they could use to crack the code. So, all right.
And then we made a bad movie about old Nick talking.
Yeah, yes. It had Nicolas Cage in it, though.
I know. It had Nicolas Cage.
All right. So on the bottom here, you should have said 5x comes out, and you have x minus 1. Did anybody defeat that little part of the problem? Good. Plus 1 over x minus 1. Minus 3x plus 2 on the top here and on the bottom. This part could get factored, and just think about it. This has an x minus 1 and that has an x minus 1. Probably isn't this going to have an x minus 1? You could have probably made yourself your life a little easier by noticing that and then saying, okay, well, then this has to be x plus 5 to make that work. Outside, inside, yep, that all works. Okay, now think about it this way. They all have an x minus 1 now. This one has a 5x, so they all have to have a 5x. So this one needs a 5x, and this one needs a 5x. Now all have a 5x. Last is this one, a little x plus 5. Everyone needs a little x plus 5. So I need to put an x plus 5 right here, and an x plus 5 on top then to cancel it out. And here, a x plus 5, and here, an x plus 5. Now, do you agree that all three of them have the same denominator? All right, then the final answer, if you did do it right, would have a denominator, of course, of 5x, and it doesn't matter which order you put the blocks in, x plus 5 and x minus 1, those three parts. And the top, here's the hard part, would be, I'm going to multiply this out, x squared minus 2 plus 5 is plus 3x minus 10 plus 5x squared, because I'm multiplying it out here. I'm skipping over the 1 because 1s don't do anything. 5x times the 5 is plus 25x. Minus, and this is careful with the minus thing, the top part of this last one, minus 15x, and oh, so easy to forget this, distribute the minus 10x. Wait, did I have it squared? Yes, thank you. And then I have to put all of this together and then check it. That, and that, and that all to go together. So the top would be, let me think now, that's going to be negative 10, and 1 makes negative 9x squared. 28 minus the 10 would be plus 18x minus 10, all over the same denominator. Did anybody defeat Hitler? Who had it? Sweet. That's like 6 of you. I only had like 3 last hour. Nice work. Okay. That is the hardest kind of problem that you have. All right. Now, would you even test you on something that hard? Probably not. That's brutal. But that's encompasses all the aspects of it. Common denominators with polynomials. Yes, ma'am. Okay, hold on. The x's part you're talking about, would you agree that that's one of my x parts? 3x. And that makes a total of 28x. This last one is a negative 10x. And I know you might not think it is. Let's look back at the original problem. You might be thinking, well, wasn't it a positive 10x? Nope. That has to be affected by this negative again. Remember how the negative has to go to all the parts of it? This part and that part? So that's got to be a negative 10. So if you put these all together,
oh, I just added it wrong. I had it right at the end until I added everything together.
you get positive 18x. Well, you saw me make a little mistake too. If all you did was one little mistake, then you understand the process and don't worry about it. There's so many steps. There's probably 38 steps. You make one little mistake in a 38-step problem, you get it wrong. And that's why we probably won't have anything that hard on your test. Almost. All right. Who is... I think you're ready. I don't even need to ask. So let's take out your homework. Actually, we need to grade last night's homework first. So let's take out last night's homework and